Hi everyone, how are you doing, guys? I hope you are doing great. Okay, so guys, in the last class we did the first chapter, right? Okay, and in the first chapter we did the first lecture. In today's session, actually, we are going to move forward. Okay, in that particular a sequence, and we are going to learn more about Euclid's lemma. We are going to see that how we going to use the Euclid's lemma. Okay, at the same time, we are going to learn about a fundamental theorem of arithmetic. That's a very important theorem. We are going to learn that theorem as well in today's session. Okay, so stay tuned with us and let's start. Okay, so let me share my screen, guys, and then we are going to start with this chapter. Okay, so I hope my screen is visible to everyone. Let's do the slideshow of it. हाँ, slideshow तो करना पड़ेगा ना, फिर समझ में आता अच्छा हमें अच्छे से ना. Just a second, let me do the slideshow. Hold on a minute. From beginning, okay. Yep. So guys, as I told you that this chapter is actually important, a real number. It's important in the board is like 6 marks chapter, right? So it's really important. Okay. Yeah. And after that, next thing we can see over here is that what we are going to study in today's session, we are going to learn about how to find the HCF by using the Euclid's lemma. After that, we will also understand the application of Euclid's lemma, and there are some problems based on that. And we will also discuss today the the fundamental theorem of arithmetic. Okay, so let's move. Let's get started. Guys, in the Euclid's lemma, in the previous class, we already understood that any number a can be written as bq plus r, right? Okay, and basically there are two positive numbers a and b, so that a can be written as in form of b, right? And we also understood that here is q is actually quotient and r is the remainder, right? And the remainder is always lesser than the quotient. Okay, and sorry, lesser than the divisor, and it is always more than or equal to 0. So यहाँ पे एक problem है. यहाँ पे it's not be equal to, it will be like that 0 more than r and lesser, it will be lesser than b. It would be lesser than b, it cannot be equal to b, right? That's something wrong over there, right? Okay, HCF is the largest number which exactly divides two or more positive numbers. Yeah, absolutely, we know about that, right? What is HCF? Guys, HCF is highest common factor, right? What is your HCF? It is highest common factor. And when I'm talking about the highest common factor, you have two numbers, okay? You have to find a highest number which is dividing both the numbers, right? Okay, for example, you have two numbers, 21 and let's say 36. So tell me a number, the highest number which is divide both of them. That's 3, right? 21 is divisible by 3 and 7. 36 is divisible by 3. It is divisible by 6 as well, 12 as well. But the 3 is the highest number by which both of them are divisible, right? So the HCF of 21 and 36 is what? It's 3. Got it? Okay, so but yeah, absolutely, we know how to find the HCF, sir. But what we are going to learn over here, we are going to learn over here the HCF by using the Euclid's division lemma. Okay, so guys, what the Euclid's division lemma say that by Euclid's division lemma, we mean that on dividing both the integers a and b, the remainder has to be 0. And when the remainder will be 0, at that time your divisor is your HCF. Okay, I will explain this by a question. Look at this, guys. So you have to find the HCF of 65 and 495. Okay, look at this. So a smaller number is what? 65. You can write 495 equal to 65 times how much? 65 into 8? That would be no 7, right? Okay, because 65 into 7 would be 7 6 are 42 and 7 7 7 5 35. It would be 455, right, guys? 455. If 455 would be there, 40 would be the remainder, right? Okay, everyone. Now you are going to write that I can write the divisor 65 as 40 into 1 plus 25, right? And then you can write 40 equals to 25 times 1 plus 15, right? Getting it, everyone? Okay, now I can write 25 as 15 into 1 plus 10, right? Oh my god, it's going on like that. I can write 15 as 10 into 1 plus 5, right everyone? And at the last, I can write 10 as 5 into 2 plus 0. And finally, by using the Euclid's division lemma, we are getting the remainder as 0. Right, guys? So when the remainder is 0, as I told you, the time at which the remainder would be 0, at that time, whatever is the divisor, that's 5 over here, that's gonna be your HCF. And that is what? 5, right everyone? The process is, we need to understand the process. The process is very easy. First of all, we are writing we are dividing actually 495 by 65, and we are writing that 495 equals 65 into 7 plus 40. Then 65, earlier it was divisor, now it would become the what? It would become the dividend. And 40 was the remainder, it would become the divisor. Okay, every step the same thing happened. Look at this now. This will remain here. Yahan pahunch gaya. Same thing is over here. Look at this. Every time in the next step, what is happening? Every time in the next step, your divisor will become the dividend and your remainder will become the divisor, right everyone? And by that, you are getting the HCF as 5, right? अच्छा इसमें एक बात और है, if you want, तुम यहाँ पे you have to show it, right? तुम ऐसे लिख भी सकते हो that okay, यहाँ पे जो हमारे पास remainder आया 40 है, divisor was 65, right? So yeah, 40 is lying in between 0 and 65. Okay, and then okay, this time your remainder is 25. You can show that okay, fine, 25 is more than 0, and but it is less than what? It is less than 40. So you can show this as well. That would be telling the examiner okay, you have a quite idea about it. Fine, simple है? Quite out. Simple question था, right? Not a difficult one. ठीक है गाइस, तो ये सॉल्यूशन दिया हुआ है इसका, एंड वी ऑलरेडी लर्नड इट, सो देयर इज नो नीड ऑफ दिस, राइट? अच्छा, इसमें बिग फोर एप्लीकेशंस, ओके फाइन. सो एप्लीकेशंस के अंदर देखो गाइस, द बेसिस ऑफ यूक्लिडियन डिवीजन एल्गोरिथम इज यूक्लिड डिवीजन लेमा. इन द सिंपल वर्ड, यूक्लिड डिवीजन लेमा सेज दैट व्हाटएवर you divide an integer by another integer, you will get a unique quotient and a unique remainder. Absolutely, that we know, right? Whenever you are dividing a number by other number, you will get a unique quotient as well as a unique remainder. Fine. अब देखो, ये अच्छा क्वेश्चन है. He is saying that an odd positive number n is written as follows. What is the value of m? Guys, odd positive number है n, and you are writing an odd positive number as 4 times k plus m. Up, if you look at the Euclid's division lemma, if I concentrate on that, can't I say that okay, basically what is happening over here is this n is behaving as a dividend, right? N is behaving as a dividend, and you are saying that dividend equals to divisor into quotient plus remainder. 4 is the divisor, k is the quotient, and m is the remainder. So अब ये दिमाग में we need to understand that point only, that if any odd positive integer is divided by 4, what could be the possible remainders? Okay, देखो, it's very simple now. When you are dividing an even number with 4, if you are dividing any number by 4, what can be the possible remainders? Possible remainders irrespective of values of n is 0, 1, 2, 3. Because when you are dividing a number by 4, you can get the remainder either 0 or 1 or 2 or 3, right? But as we are talking about that n is an odd positive number, what you will write that? But as n is odd positive, so 0 and 2 is not possible. If you are getting the remainder as 0, that means the number is divisible by 4. If a number is divisible by 4, तब वो odd positive कहाँ है? Then the number will become even number, no? And if you are saying that, sir, no, sir, what about 2? If you are dividing a number by 4, you are getting a remainder as 2, right? That means the number is an even number. It is 4 times of something plus 2. Even plus even is even, ना? जैसे for example 6 है. Dividing by 4, remainder is 2. 10. Dividing by 4, remainder is 2. But वो even number है. We have to deal with odd number, right? So 0 is not possible, 3 is not 2, 2 is not possible. So basically, what is the value of m that is possible over here? It can be either 1 or 3, right? So whenever you are dividing an odd positive number by 4, the remainder can be 1 or 3. अब देखो, यही तो understanding है. This is the understanding of the question. It is not given to you. It is not given to you in the question that you are dividing a number by 4, and he is not saying that okay, when you divide a number by 4, what is the remainder? Tell us about that. No. That we need to understand ourselves that okay, you are saying that a number n is written as 4 times of k plus m. That means what you want to convey, that a number n is a multiple of 4 plus something. Multiple of 4 some plus something means that you are dividing a number by 4 and something that m is the remainder. Got it? Okay, let's move forward. Perfect. देखो यहाँ पे दिया हुआ है उन्होंने solution. M can be 0, 1, 2. यही मैंने आपको बताया है. Okay, so the value possible values can be, it can be either 1 or 3, right? Okay, got it? Okay, perfect. So guys, अभी हम बात कर रहे हैं यहाँ पे the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? That means over here, देखो एक सेकंड रुको बस आप लोग, ये हाँ पेन थोड़ा सा इशू कर रहा था. Fundamental theorem of arithmetic means it states that any integer greater than 1 is either a prime number or can be written as a unique product of two prime numbers. Pay attention guys. ये theorem is saying that there is any integer if it is a greater than 1, तो या तो वो एक प्राइम नंबर होगा. अच्छा बहुत सिंपल है, कोई भी नंबर अगर मोर देन 1 है तो या तो प्राइम है या वो कंपोजिट है. If a number is more than 1, either it is a prime number or a composite number. If it is a prime number, it is a prime number because it is saying na either a prime number or it is a composite number. But if it is composite, then it can be written as product of primes. Absolutely. So यही तो ये बोल रहा है. अरे ये हमें आता है already. हम अब जैसे आप just close your eyes and you think about it. Okay, if a number is more than 1, what it could be? It could be either a prime number or a composite number. Okay, if it is a composite number, it can be written as the product of prime numbers. For example, 8 is a composite number. 8 is a composite number. It can be written as 2 into 2 into 2. It can be written as the product of primes. Okay, got the point? Okay, everyone, 42. यहाँ पे देखो बहुत अच्छा example है. 42. 42 is a composite number. It can be written as product of one or more primes. Absolutely, it is. 2 into 3 into 7. हाँ उसने भी definitely. अभी कोई बोलेगा सर unique नहीं है सर. Why you are saying it's unique, sir? I can write 3 into 2 into 7. You are writing 2 into 3 into 7. That's not unique. अरे बाबा रुको. This is unique because order doesn't matter. Order देखो वहां पे लिखा हुआ ना ब्रैकेट के अंदर, ignoring the order. You can ignore the order, right? You can tell me any number in the world. It is either a prime number or it can be written as the product of prime numbers. आप बताओ ऐसा नंबर जो पॉसिबल नहीं हो ऐसा करना. हर नंबर है पॉसिबल. 23 सर बताओ. 23 is a prime number, man. Sir 24, sir 24. Nice question. 24 is what? 2 into 2 into 2 into 2 into 2 into 2 into 3, right? 8 into 24, right? Product of prime, 2 is a prime, 2 is a prime, 2 is a prime, 3 is a prime, product of primes. Okay? Got the point? So fundamental theorem of arithmetic is actually we already known. Okay, right now we are just looking at the other way of this theorem, right? Okay, let's move forward then. Okay guys, so यहाँ पे you have a video as well, okay, that you can play after, like whenever you feel fine. After the class definitely. अभी तो मैं समझा ही रहा हूँ. Explain why this number is a composite number. Arey, what is a composite number? A composite number is a number which can be written as product of primes. That's what we have just learned. We need to show guys that this number can be written as the product of two prime numbers, right? So इसमें दो तरीके बनते हैं. What some people will do, some people what क्या करते हैं? Some people means these people I'm talking about, not quite happy. These kind of people, what they do? They first of all multiply 5 into 4 20, 20 into 3 60, 60 into 2 120, 120 plus 3 123. So अब वो क्या करेंगे, पहले तो बोलेंगे 123, नंबर को लिखा 123. Then what they will do, they will try to prime factorize it. Okay, they will say okay divisible by 3, right? So 3 ones are 4 3s are 12 and ये 1 बच गया. 41 seems it's like a prime number, right? 41 और ये 1 आ गया, right? So basically 123 is what? It is 3 into 41. And what is 123? It is 5 into 4 into 3 into 2. The given number is 41 into 3. It can be written as product of two primes. And whenever you can write a number as product of two prime, it is composite number. Okay, method number 1 is this. This is method number 1. But okay, what is the happier method? ज्यादा अच्छा ये होता अगर let's say यहाँ पे कोई if it's a big number ना, then you might get stuck. Okay, don't get stuck. What you will do? Simply take 3 common. So it will remain by 5 into 4 into 2 into 1 plus 1, right? Okay, it will become 3 into something, 5 into 4, 20, 41, right? It is 3 into 41. Simple. Are you getting the difference between the both two methods? Ultimately you are getting 41 into 3. उसने पहले आपने मल्टीप्लाई किया फिर फैक्टराइज किया. इट्स अ डिफिकल्ट मेथड. यहाँ पे हमने सीधा कॉमन लिया, आंसर आ गया. Okay, the given number is actually 3 into 41. That means the given number is actually the product of two primes. And whenever a number is product of two primes, it is a composite number. Problem solved. Let's move forward, guys. Got it now? Doubt to nahi hai? Okay, let's move. So guys, next question is that in a formula racing competition, the time taken by two racing cars A and B to complete one round of a track is 30 minutes and 45 minutes. After how much time will the car meet against the starting point? Pay attention on the question. It's a very simple question actually. Okay, but still we need to pay attention on the question. Look what the question wants to say. Question is saying कि ऐसा ना ये ट्रैक है, फॉर्मूला ट्रैक, ठीक है. कार वन यहाँ से स्टार्ट होती है और पूरा पूरा सर्कल कंप्लीट करके वापस यहाँ पहुंचती है 30 मिनट्स में. And car to also start with the same track, but complete करती है पूरा सर्कल और यहाँ कितने टाइम पहुंचती है 45 मिनट पे पहुंचती है. ठीक है, अब देखो क्या सिचुएशन क्या हो रहा होगा. आफ्टर 30 मिनट्स कार वन विल फिर से अपने स्टार्टिंग पॉइंट पे होगी. अगेन आफ्टर 60 मिनट्स इट वुड बी अगेन एट द स्टार्टिंग पॉइंट. फिर 90 पे अगेन स्टार्टिंग पॉइंट, 120 पे अगेन स्टार्टिंग पॉइंट, 150 पे अगेन स्टार्टिंग पॉइंट, राइट. कार टू 45 मिनट पे अगेन एट द स्टार्टिंग पॉइंट. Then 90 minute पे again for the starting point, right? Because 90 minute में again one more circle complete हो जाएगा. Then 135 minutes again at the starting point. Okay. Then 180 minutes again at the starting point, right? If you look at one thing, that at 90 minutes both the cars were at the starting point, right? So he's saying that at how much time, after how much time will the cars meet again at the starting point? So after 90 minutes both the cars will meet at the starting point. Are you getting the problem, guys? एक बार फिर समझाता हूं मैं. अभी you are standing over here. Okay, you will complete a cycle in 30 minutes. 30 minutes में again you are here. Then you again complete a cycle in more 30 minutes. Again you are here. 60 minutes में वापस यहाँ पे होंगे you will, right? 30 में यहाँ पे again 60, 90, 120, 150, dan. You will be on the same point again. Now if I talk about the other car, the car 2. If you are traveling with the car to 45 minutes may will be again at the first position, same position, I mean, from which you have started. Then again 90 minutes में वापस यहीं पे. Then 135 minutes, then 180 minutes. So at 90 minutes, either talk about the car 1 or car 2, both of them are the same position, right? Both of them would be at the same position after 90 minutes. So that was the complete explanation, conceptual explanation of the question. But how we have to solve actually? You can directly solve, guys. Very simple question. You just need to find the LCM of 30 and 45. Okay, so what is the least common multiple of these two numbers? I hope you know about how to find the LCM. Okay, so LCM would be what? 90. Okay, so after 90 minutes these two cars will reach or will meet. Why I am finding the LCM? Because LCM is telling me that at what time they are going to meet at the first, okay, at the starting position, I will say starting point, right? Okay, so I explained the concept, but now if this kind of question comes in the examination, you just need to find the LCM to get the answer, right? Okay, LCM of both the given numbers to get the answer, right? So यहाँ पे दिया हुआ है same is 90 minutes is the answer, and we also got it. Actually, that's not a problem for us, right? Okay, guys. So now, if I talk about in today's session, we have learned, how to use the Euclid's lemma in the questions, how to find the HCF using that. We have also learned about the fundamental theorem of arithmetic. So guys, the question was here based on you have to find the HCF of these two numbers by using the lemma. Okay, same thing. The cube of a positive number is divided by 9. So what can be the possible remainders? And express 1080 as the product of prime factors. Is this factorization unique? देवी आप लोग कर लोगे. थर्ड क्वेश्चन एक बार सोचिए जरा कैसे कर सकते हो. The cube of a positive number is divided by 9. You have a positive number. It can be either even or odd. If it's divided by 9, it's का cube किया आपने number का, and then you are dividing it by 9. So what can be the possible remainders? Think about it. I mean, like, just it's like that kind of question, when I'm saying you to find the remainder, definitely you know one thing, that if you're dividing a number by 9, the remainder can be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? But you are not dividing a normal number, you are dividing cube of a number. Okay, देखो, let's say या तो number क्या होगा? Let's say the given number is either the real number would be 2n or 2n plus 1, right? या तो odd होगा even होगा. If you are doing the cube of the number, what you are getting over here, you are getting 8n cube or 2n plus 1 whole cube, right guys? So if you are doing the cube of the number, you will get either 8n cube or you will get a cube plus b cube plus 3 into ab into a plus b, right guys? 3ab into a plus b. So if you solve, it would become 8n cube plus 12n square plus 6n plus 1. So either you are having the first number 8n cube or you are having the second number, that is 8n square plus 8n cube, sorry, 8n cube plus 12n square plus 6n plus 1. Out of these two numbers, if you are dividing any number by 9, what could be the possible remainder? Think about it now. Socho. N can be any number. 1, 2, 3, whatever. Yep. Think about it. Answer बता दूं? Okay. तो इसका आंसर वो 0, 1 और 8 है. The answer can be either a 0 or a 1 or a 8. अब तो मैंने आपको आंसर बता दिया, आप तो सोच सकते हो, सोचिए. It can be either 0 or 1 or 8. Think about it. नहीं आ रहा है. Actually, it's as I told you, it is a good question. यार, you need to think. सोचोगे तो आंसर आ जाएगा. हाँ, सोचना तो पड़ेगा यार. Think about it. ओके गाइस, सो एज आई कैन सी कि अभी आप लोगों का आंसर नहीं आया इस क्वेश्चन का. जस्ट अ सेकंड, वो स्लाइड शेयर से रुक गया था. लेट मी जस्ट शेयर इट अगेन. ओहो, फाइन फाइन, कोई प्रॉब्लम नहीं है. जस्ट अ सेकंड गाइस, जस्ट अ सेकंड. हाँ, तो वी वर ऑन दिस क्वेश्चन, राइट? सो देखो, अभी इसका मेथड जो है मैं आपको बता देता हूँ कि इसका हाउ टू सॉल्व दिस काइंड ऑफ क्वेश्चन. एक्चुअली इसमें थोड़ा सा एक इशू होगा, तो लेट्स नॉट यूज दिस वन. वी आर गोइंग टू यूज अ डिफरेंट मेथड. देखो, अगर एक नंबर है, if you are dividing that number by 9, you have to find the possible remainder if the number okay, fine. So guys, if there is any number in the world, if you are dividing, okay, can I write the number in terms of 9 as the number can be 9n or 9n plus 1 or 9n plus 2 up to 9n plus 8, right? If you are doing the cube of this number, देखो, दुनिया के all the numbers in the world can be written as this form, right? 9n, because if why how you are saying such that? It's very simple. I'm saying by Euclid's lemma. Okay, that if you are dividing any number by 9, the remainder can be 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, by that. Okay, ठीक है ना? तो अब इस वाले केस में आप लोग क्या कर सकते हो कि if you are doing the cube of this number, you'll get 729n cube. And that is divisible by n, so 729 नहीं आएगा. हाँ, 729 आएगा. And if you are dividing this number by 9, the remainder would be 0. अब यहाँ पे if I are doing 9n plus 1 का whole cube, तो क्या आएगा? देखो, a cube plus b cube plus 3ab into a plus b, right? So 3 into 9n into 9n plus 1. If you divide this number by 9, the remainder would be 1. ऐसे आप सबके साथ करोगे, right? So ultimately what you will see is that the remainder would be either 0 or 1 or 8. तो यहाँ पे करोगे तो remainder 8 आएगा. तो यहाँ पे 0 आ गया and 1 and then 8. Now if you do the same thing with 9n plus 3, remainder 0 आएगा. फिर 9n plus 4 के साथ remainder would be again 1. 9n plus 5 के साथ it's again 8. 9n plus 6 के साथ it's again 0. 9n plus 7 के साथ it's again 1 and 9n plus 8 के साथ it's again what? 8, right? So ultimately if you are dividing the cube of a positive number, the possible remainder that you are getting is either a 0 or a 1 or a 8, right? I hope you got this question, guys. This was a good question. Okay, so I'm saying what I did is basically that first of all we have assumed the number in terms of 9n. So the number can be 9n plus 0, 9n plus 1, 9n plus 2, 9n plus 8. Because any number in the word, if you are dividing that number by 9, the remainder can be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, and if you are अब इसका cube करोगे पहले. Cube करने के बाद you will again divide it by 9. You will get to know कि after doing the cube, if I am dividing it by 9, the remainder is either a 0 or a 1 or a 8, right? Got it? Simple था? Chalo, ठीक है guys, then that's it on today's session. Other 3 questions are the homework and you have to put the doubts on PDF that you already know. In case of you are facing any issues, I'm always available for you guys to solve your problems, right? Okay, just मेरे को लिख देना आप लोग that, okay, sir, we have this doubt on PDF and I'll explain your questions. Okay. Bye-bye. Take care. Have a nice day ahead, guys. See you. Bye-bye.